Hey chemistry students, I'm Sophia Frank, and in this video we will be looking at the Bohr model. Before Bohr, many other scientists had attempted to predict what the atom looked like. Let's quickly look at some of those models. One of the first scientific models of the atom was created by John Dalton. Dalton did several experiments with gases and was soon able to determine that all elements consist of atoms. He also created a model of these atoms which was simply just a sphere-like structure. After Dalton, the electron was discovered, a huge milestone on how we perceive the atom. Thomson set up experiments using cathode rays and concluded that atoms were made up of negatively charged electrons which were inside positively charged matter. This was known as the plum pudding model. A few decades after Thomson, scientists began to see several flaws in his model. A series of experiments using alpha particles and gold foil was created that proved some of these models wrong. Rutherford took these experiments and created a new model for the atom. He created a model made up of mostly empty space with all of its positive charge tightly packed in the middle, surrounded by a cloud of electrons. Just like scientists before him, Rutherford's model wasn't perfect. Niels Bohr came along and identified some flaws in Rutherford's model. Now, let's look at the Bohr model. The Bohr model is composed of a nucleus that is positively charged with an equal amount of negatively charged electrons surrounding it. Rutherford saw the atom as a atom like the solar system, but his view was flawed. The model Rutherford used included predictions from classical mechanics which explained that the electrons constantly emit electromagnetic radiation. The problem with this, that Bohr later discovered, was that the electron would lose energy while emitting this radiation, causing the electrons to eventually fall into the nucleus. Bohr resolved this problem by proposing that electrons can gain or lose energy by jumping from one allowed orbital to another, gaining or losing electromagnetic radiation while this occurs. Although the Bohr model isn't the basic atomic model we use in chemistry today, there were errors. One error was that the model assumed that electrons have a known radius and orbit. This was later proved wrong by the Heisenberg uncertainty principle. Besides from these slight errors, the Bohr model is very useful to predict the behavior of electrons in small atoms like hydrogen. Unfortunately, it cannot be used for larger elements. Thank you for watching my video. I hope you enjoyed listening to the history of the Bohr model. Have a good day!